Good morning, students. So, welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and Mastermind Schools. So, once again, I welcome all the class 8 students for today's session. As you all can see on the screen, my subject is physics. We are in class 8th. Our ongoing chapter number 7, that is sound and wave motion. And today we are entering into the session number 2. So already we completed the one session in understanding the what is the form of energy, sound. We discussed about the sound, how sound is produced, how sound is propagated, can we hear all the sounds or not, everything about sound we learned, right? So we'll continue where we left in the last class. But before that, let us recall, let us review what we learned in the session number 1. Okay. So these all are the various sound sources, right? The sources of sound. They may be natural or artificial. Natural sounds comes under thunder, lightning and all. These all are comes under artificial source of sound. See, there are so many are there. Speaker, headphones, okay. And so many, the sound produced by us and sound produced by various musical devices. It may be guitar, veena, violin, flute, tambura, tabla. So many are there, you can see. All these are the various artificial sources of sound. Okay. So what is sound actually? The sound is a form of energy which is pleasant to hear. Very important one. Which is pleasant. It should be very smooth to hear. Pleasant to hear. Or which produces pleasing effects on eardrums. Or which creates sensation on eardrums. Is called sound. Opposite of sound is noise. So noise is the reciprocal of sound, which is unpleasant to hear. So all of you know noise, all the students, because whenever teacher comes into class, she will shout that don't make noise. She won't use the don't make sound. Sound is very good to hear, whereas noise is irritating to hear. So which is unpleasant to hear is called noise. Pleasant to hear is called sound. Okay. So all we know that sound is produced by vibrating body. Every vibrating body produces sound. Right? That or not? Where there is a vibration is there is a sound will come. Where there is no vibration, no sound. So whenever sound is produced from any source, it travels in the form of wave. Sound travels in the form of wave. Right? Just a minute. So sound travels in the form of a wave. We'll see what is wave actually. It travels in the form of wave and it required medium for propagation, medium for traveling. Without medium, sound cannot move forward. Right? Means sound does not travel through vacuum because vacuum is nothing but absence of medium. As you have seen in the lower classes, bell jar experiment. Even though bell is hitting the gong, the hammer is hitting the gong, we cannot hear sound when there is no air in the bell jar. Right? That we have clearly understand that sound required medium, either it may be solid medium, liquid medium, or gaseous medium to travel. Okay. So, already we discussed in the last class about periodic motion, the regular motion, to and fro motion of the body. It is also a part of sound only, right? Then there are so many things to discuss here. So now, all this we've seen, how the simple pendulum will move to and fro. And how the sound travels in the form of a wave. So what is a wave? So wave is nothing but disturbance created in a medium. Disturbance, so disturbance only. Disturbance. So disturbance created in the medium is called a wave. I will tell you simple example. For example, you take one small stone and drop in water. You have pond of water is there, you drop stone. So what happens? Wherever stone is disturbing the particle, we can see the formation of the water waves. Right? You can see the formation of water waves. What happened here? A wave formation takes place because of the disturbance. Take one rope, tie to one end, and second end, you pluck it like this. You pluck. So you can see the formation of waves. Means wherever disturbance is there, either it may be in solid, liquid, or gases, wave formation takes place. So a disturbance created in the wave is called, the disturbance created in the medium is called wave. So what happens when disturbance is created? The energy transferred from one particle to another. The particles won't move. Particles never move. Water particles, they are not moving anyway. They are transferring energy to next particle. By transferring energy, the wave formation takes place. That is called wave motion. Suppose if we have a pond of water, a water in beaker, okay, you disturbed here, you drop a stone here. So stone disturb the particles here, and that particle supply the energy to next particle, like that. The wave moves to other end. Particles are remaining there only. They are not moving. Just they are transferring their energy. Such motion is called wave motion. The motion of wave by transferring of their energy to next particle is known as wave motion. So wave and wave motion. So whenever you are getting these terms, some important terminology also you can. But before that, I will show you one small video on the wave motion. Then we'll move to the further explanation, right?
Ever seen a Mexican wave at a sporting event? The effect is a pretty cool display that goes all around the stadium, but no one has had to move seats. All waves can transfer energy from one place to another without transferring any matter. This is done by a series of disturbances or vibrations that carry the energy. Just like the people in their seats only moving up and down when it's their turn. Waves can transfer energy through solids, liquids, gases, and empty spaces, otherwise known as vacuums. There are two types of waves, which we look at in more detail in another video, but the basic features are the same. These four words describe different properties of waves. Let's discover what...
All the waves will have these properties: frequency, time period, wavelength, amplitude. I will explain you after this.
Each one means. The frequency of a wave is the number of complete waves passing a fixed point in a given amount of time. This time period is usually 1 second. This is what one complete wave looks like. So if this was our time period, the frequency would be 5. Frequency is given the symbol F and is measured in units called hertz. Hertz measure how many complete cycles per second. So how many people in our Mexican wave stand up every second. The frequency and period are often confused. The frequency refers to how often something happens, whereas the period refers to the time it takes to happen. The period of a wave is the time for one complete cycle, so the time taken for one person to stand up, wave, and sit down. This would be measured in seconds. When something happens repeatedly, we say that the event is periodic and refer to the time for the event to repeat itself. The period of the Earth to orbit the Sun is 365 days. The period of a day is 24 hours. The period of a typical class at school is 45 minutes.
Classroom.
Now for wavelength. The wavelength is the distance between a point on one wave and the same point on the next wave. For example, 2 peaks or 2 troughs. Wavelength is given the symbol lambda from the Greek letter and is usually measured in meters. Wavelengths can vary hugely in size. X-rays are very short, visible light is here, and FM radio waves are much longer. So we've looked at the frequency, period, and wavelength so far. Let's finish with amplitude. As waves travel, they create disturbance. The amplitude of a wave is the distance from the maximum disturbance to the undisturbed position. Think of a very flat sea, and then an incoming wave. The amplitude is the height of the top of the wave from the flat sea. Can you add the labels to these waves and work out the frequency? Notice that the top one is distance and the bottom one is time. Pause the video, work it out, and click play when you're ready.
Okay, so what he explained, he's trying to explain here is the terminology related to wave motion. Whenever we are discussing about the wave, we'll come across few terms. So wave is nothing but disturbance created in the medium. The medium may be either liquid, solid, or gas. But whenever body is moving, they just transfers energy. There won't be any movement of particles. The particles never move to the next position. They transfer energy to next particle. Like that, the wave move forward. Such motion of a wave is called wave motion. So when we are discussing about the wave motion, we'll come across few important terms. Few important terms will come across. Some parameters will come across. So you can see here, before going to know about the types of waves, wave parameters. Okay. So first one, anyway, the order may be different. First one is frequency of the wave. So frequency, what is frequency? Frequency is nothing but number of vibrations. Number of vibrations made by a particle or wave. Number of vibrations made by a wave in 1 second. In 1 second is called frequency. That is generally represented by n. N is equal to 1 by t, where t is called time period, 1 second. So this is, and it is measured in units called hertz, H-E-R-T-Z, and short form is Hz you can represent. So hertz is the name of the scientist. So first every wave will have the frequency. That means the number of vibrations. How many vibrations is made in 1 second? Whether particle or a wave. Number of vibrations made by a wave or a particle also you can write. If you consider the particle, you can write particle also. Right? Is known as in 1 second. In 1 second, how much vibrations made? Right? Is called a very, very important property. Based on this property only, you can able to hear the sound. Whether some sounds can be audible, some cannot be audible, which depends on this property, frequency, which is mathematically given by n is equal to 1 by t. Or sometimes they represent f also, small f. And it is measured in units called hertz. Okay. Number 2, time period. Because when you are discussing the frequency, the time period, that is capital T. So time period is nothing but the time taken by a particle to complete one vibration. So number of vibrations is frequency. Time taken is known as, so time taken by a wave to complete one vibration. Top to bottom, bottom to top, one complete, how much time it takes. That is called time period of the. So no doubt time as it is measured in the seconds only, which is the reciprocal of frequency you can call. Right, for example, Earth rotates around the sun. It takes the 365 days to complete one revolution. Or Earth takes 24 hours to rotate around itself, spin around itself. That is also time period. Time period will give us day. Time period will give us year also. So it depends on that. That is called time period. Okay, frequency, time period, which are related. Reciprocal of time period is nothing but frequency. So frequency is nothing but number of vibrations made by a particle or a wave in 1 second. In 1 second. And how much time it takes to complete one vibration is called time period. So all are the wave parameters, right? When you are discussing about the wave, we'll come across all these properties. Right. Next, we'll come across is wavelength. Very important one. Wavelength. When you consider any wave, for example, a wave like this. So this is the distance between the two particles which are in same line, either here or here. This is taken as wavelength. The distance between the two particles which are in same phase, technically called as phase. Phase means which are lying on same line. When you join, they are meeting here, see. So this is called the wavelength, which is represented by a Greek letter lambda. Lambda symbol reverse Y. It is measured in meters or centimeters as usual, because this is also a distance only. So wavelength is nothing but the distance between the two particles of a wave which are in same phase. When you are drawing a line, see here clearly shown. This is the wave, here is the wavelength. Or this is also wavelength, because they are in same phase. They are in same line. Phase is the mathematical word, right? It's called wavelength of a wave. And one more given here is amplitude. Amplitude is nothing but maximum displacement. Maximum displacement of particle. See, for example, what is the maximum displacement here? Up to here on maximum. So particle is moving from here, maximum is here, again come back. So either maximum upward displacement or maximum downward displacement of a wave is called amplitude. Maximum displacement of a particle or a wave from its mean position is called amplitude. So maximum displacement of particle is this. Maximum displacement of wave is up to here, A to B. Is considered as a amplitude of a wave denoted by again A, and measuring the same meters or centimeter, because this is also a displacement. Okay, this is the four terms. Next, finally, very important one is there, velocity, wave velocity. You know, velocity, distance by time. But wave velocity is the distance traveled by a wave in 1 second. Velocity is nothing but distance by time. So distance traveled by a wave in 1 second is called wave velocity. So what is the distance here in case wavelength? In case of wave, distance is nothing but wavelength lambda by t is nothing but time period. So v is equal to lambda by t. Or you can write v is equal to lambda into 1 by t, same meaning. But what is 1 by t? 1 by t is nothing but n. So you can write v is equal to n lambda is the formula for velocity of the wave. See, try to understand here. Simple. Common definition of wave is displacement by time, right? Rate of displacement. But in terms of wave, displacement is nothing but wavelength, right? Wavelength by time in place of time, time period. V is equal to lambda by t. But you can write lambda by t as lambda into 1 by t, same meaning. We know 1 by t is nothing but frequency, the number of vibrations made by a particle in second. So in place of 1 by t, n. So you got the formula V is equal to n lambda. It's a very, very important formula in sound. So either you can write V is equal to lambda by t as per the given data. Suppose they give time period, ask to find velocity, we can use this formula. If they give frequency, we can use this formula. Right? So what we learned, 5 important terms. Number 1, frequency of the wave. Number 2, wavelength of the wave. Number 3, time period of the wave. Number 4, amplitude of the wave. And the 5th one is velocity of the wave. Right? Velocity, which is given by the formula V is equal to n lambda, or V is equal to lambda by t. Clear? So these are the very, very important points regarding the wave, regarding study of waves. Okay, then we'll see some more information is there. So what is phase? I told you phase is nothing but lying on same line. The motion of the vibrating particles and their direction is described in the term of phase. How they are moving, whether they are moving same line or not. If they are moving on same line, they are said to be, for example, wave is like this. So see, every point they are at same pace only. Suppose wave forms like this, later it decreases like this. This is damped, decreasing time to time. But this is called they are in pace. So So this is decided by the direction of the particles, right? So if the motion of the two particles is such that their displacement, motion, and velocity are dissimilar each other, then they are said to be phase difference. If they are not on same line like this, they are said to be having phase difference. If they are on same line, they are in phase. Lying on same plane is called phase as per the mathematics. Okay. Then transmission of energy. How energy transmits? Energy is nothing but sound, we can say. Sound is energy. It is found that certain types of waves requires a medium for propagation. Correct? Certain types, not all. Light can travel through vacuum also. Example, water waves, sound waves, etc. Whereas there are existing waves which do not require medium for their propagation, like light waves. So there are two types of energies. Some are required medium for propagation, which are called mechanical waves. Some are does not require medium for propagation. They are called electromagnetic waves. Clear? So mechanical waves like sound waves. Sound waves require medium. Without medium, sound cannot travel. That is the reason sound cannot travel through vacuum. Whereas light wave can travel through vacuum. They are called electromagnetic waves. Right? So based on the transmission, they are classified into mechanical waves and electromagnetic waves. So mechanical waves are the waves which require material medium for their propagation. Right? Propagation is nothing but moving. They are also called elastic waves, as the main causes for their propagation in the medium is property of medium called elasticity. Without elastic property, wave cannot form. Elasticity is nothing but, again, coming back to their old position, just like a rubber band. When you stretch the rubber band and leave it, again it come back to normal position. Similarly, in such a property should be there for the formation of wave. So every wave should have elasticity property and also inertia. Without these properties, wave cannot form. Okay, then that is called the next. If the body regains, that is the different shapes. Next, electromagnetic waves are the waves which do not require elastic medium for propagation. They can propagate through media as well as vacuum. Light waves are the examples for the electromagnetic waves. Right. So these are the two basic classification. Later, again, we'll classify into mechanical waves into transverse mechanical wave and longitudinal. That we'll discuss in the next class based on their behavior, how they are propagating, whether they are propagating to the perpendicular to the wave propagation or parallel. All the particles, how they are moving, based on that, they are classified into transverse waves and longitudinal waves. That will discuss very, very important topic in this chapter. So difference between the longitudinal and transverse waves, and difference between the another types of waves are the progressive and stationary waves, which we'll discuss in the next sessions in details. Right? In meantime, we go through the what covered topic today. So today we covered very important terms. Let me recall once, then we'll close the session. So today what we learn is, number one, we recalled about sound, no doubt. We learn about what is wave, what is wave motion, right? Then terms related to wave motion like frequency, time period, and wavelength. Then wavelength and its velocity, wave velocity, right? Then we learn about the mechanical waves and electromagnetic waves, EM waves you can call it as. Okay. So these are the terms what we learned today. So wave is nothing but disturbance created in a medium. Whenever disturbance is created in any material medium, either solid, liquid, or gas, the formation, if formed is wave formation takes place. After forming the wave, there won't be movement of particles. Particles never move during the wave formation. They'll transfer the energy to next particle and move, because for formation of waves, the condition should be the medium should be elastic in nature and it should possess the property of inertia. If these two properties should be there for the formation of wave, any medium, that medium should be having elastic property, then only you will get the waves up and down. The medium should have inertia. Then when the energy transfer from one particle to other particle, then we give the wave motion. So whenever wave started moving, the moving wave will have frequency, that is n is equal to 1 by t. The number of vibrations made by a particle in 1 second is called frequency, which is measured in hertz. Right. Then the time taken by the wave to complete one vibration is called time period, that is denoted by t and measured in second. Then the distance between the two particles which are in same pace is known as wavelength, which is measured in the lambda, measured by represented by lambda and measured in meters or centimeters, because this distance only. Then wave velocity, the distance traveled by wave in 1 second, that is v is equal to lambda by t, wavelength by time period, or v is equal to n lambda, since 1 by t is equal to n, as we have seen here. Then we learn about what is the pace also. Pace is nothing but lying on same plane. If they are not lying on same plane, they are said to be pace difference. They have pace difference. That we learn when we are discussing about the types of waves. Then based on that, based on how the waves are traveling, the waves are classified into mechanical waves, which require material medium for propagation. The second type waves are electromagnetic waves, which does not require medium for propagation, like light waves. That is the reason sunlight is coming from sun to earth, passing through the vacuum. Okay. So these are the things what we learned in today in session. So you can note down the homework for today. Define wave motion. You can find it from your material and write the answer. Show to your class teacher, that is subject teacher, and parents. Take the signature. Okay. So this is the time for the wishing you all advance Happy New Year. Today is the last day of the 2024. So advance Happy New Year for all of you. So thank you, Medicare branch. Now that's all for today. So thank you all of you. Have a wonderful day. Have a wonderful year ahead.